Hello everyone, welcome back. This is Engineer Hussein Mosapi. So in this video, we'll be looking at the applications of arithmetic and geometric progressions. Alright, so before we begin, do not forget to like and subscribe to the channel. So we're going to look at some problems that are associated with the applications of APs and GPs. Now, let's first start with this question. The question reads to say, a man saves about 16,500 kwacha in 10 years. In each year after the first year, he saved 100 kwacha more than he did in the preceding year. How much did he save in the first year? Alright, so when it comes to application of problems, the most important thing to do is to understand the question. Let's try to analyze the data that is present in the question. Alright, so we need to understand one thing, that this man saves 16,500 kwacha. So that's the total amount of money saved. So let's put that in data. So let's say total amount saved is equivalent to 16,500 kwacha. That's the total amount of money this person saved. And then we need to understand the duration in which this amount of money was saved in. So that could be regarded as a period as well, but let's just say duration for now. The duration is in 10 years. Now, what else is present here? Now, I need to understand this statement. It says that in each year after the first year, he saved 100 kwacha more than he did in the preceding year. Now, this tells you to say that if this person, let's take an assumption. Let's assume that this person was saving X amount of money in each year. So if this person is saving in each year, let's say this is the first year. So in the first year, he saved X. Now you need to understand that in each year after the first year, he saved 100 kwacha more than he did in the preceding year. So this means that in the second year, this person has to save about the initial amount plus 100 kwacha. So that would be in the second year. And then in the third year, it means what? Exactly. The person is going to end up saving about X plus 200. And then ellipsis, it keeps on going just like that. So this would be in the third year. So that's what they mean when they say in each year after the first year, he saved 100 kwacha more than he did in the preceding year. Now, the question says, how much did he save in the first year? So we want to find the value of X. Now, let's understand something. This person saved 16,500. So that is clear enough to let you understand to say that that's actually the sum of everything, which means that the total amount of money, like I illustrated in the first place. So this means that if at all we had to put this in an arithmetic type of way, it means that the sum of n terms, which is now 10 years, was equivalent to 16,500. And now this tells you to say that the value of n will be what? 10. And if at all we take the assumed sequence, we can find the common difference. We can say d is equivalent to term 2 minus term 1 or term 3 minus term 2. And if we do our computation, that's x plus 100, then minus x again. So the common difference, x to cancel out with x, will just be 100. Now, we know that the sum of n terms is equal to n over 2 by square brackets 2a plus n minus 1, then d. If we plug and check the values that we have, we can say that the sum, which is already known, which is about 16,500, if at all we put it there, is equal to, then n is 10 divided by 2. Then we have 2 times the first term, which is x, plus 10 minus 1. Then the common difference is 100. Now in this case, we have to solve for x. So by doing so, we'll have 16,500. Then 2 into 10, that's about 5. Then 2 times x, that will give you about 2x, plus 9 times 100, like that. So 100 multiplies the 9. So 16,500 is equal to 5. Then you have 2x plus 900. Just like that. Now, there's a better way we can do this. If we wanted, we can follow it out by letting the 5 multiply each term within it. Or we can just divide throughout by 5. So such that we divide throughout by 5. So 5 into 6,500 will be 3,300. And 5 in 5 in 5 will be 1. Then we'll have 2x plus 900. So basically we have 2x plus 900 being equal to 3,300. Now at this point, we then have to solve for x. So we have to find the transpose, or like my country people like to say, the 900 will jump. I don't know, by inaccuracy, it's going to jump. Let's just believe that. But anyway, we find the transpose. Then we have 2x being equal to 3,300 minus 900. Then we have 2x being equal to, if we subtract, we have 2,400 there. Then divided by 2, we have x being equivalent to 1,200. Now, this tells you to say that he saves 1,200 in the first year. So, which means that we have first year being equal to 1,000. Let's put it in kwacha form. 1,200 kwacha. And that's the amount of money this person had saved in the first year. I hope it's clear. Now let's look at a similar question like this same one. All right, so let's try to understand the next question. So the next question says that Mr. Ntemba borrows 2,000. And then this person agrees to repay with a total interest of about 340 kwacha in 12 months installments. So each installment being less than the preceding installment by 10 kwacha. Now what should be his first installment? All right, let's also analyze this question. So Mr. Ntemba borrows 2,000. So let's get the amount borrowed. So amount is 2,000 kwacha. Now, the interest that he's going to be putting is going to be about 340 kwacha. Now, what will be the total amount of money that he has to pay? So, total amount is equal to 2,340 kwacha. So this is the total amount of money that Mr. Temba has to pay in 12 months. So the duration, like I've been saying, is 12 months. Months. All right, so now let's understand what's going to happen now. The statement says each installment being less than the preceding installment by 10 kwacha. Let's take an assumption. All right, so if we're saying that each installment needs to be less than the preceding by 10, let's assume that the first amount of money that this person is going to pay in the first month, because it's in 12 months, let's assume it to be X. So this is in the first month. And then we're saying that each installment needs to be less than the preceding by 10 kwacha. So the next one will be X minus 10, which will be in the second month. And in the third month, it's going to be X minus 20. And it keeps on going, just like that. Now, what does this tell us? Now, this tells us to say that if at all we have to assume an arithmetic type of application way, we can agree to say that if at all we need to find our data then we know the total amount of money. But what is important for us to do is to know the first installment, which is the value of x in this case. So the first term is x, and n should always be the duration that you have in question, which is 12 months. The total amount of money, which is the sum, s sub 12 is equal to 2,340. The common difference can also be found here. You can say term 2, which is x minus 10, minus term 1, which is x. Now, if you cancel this out, you end up having minus 10. Now, you can also do term 3 minus term 2, which is basically by inspection. If you compute these two, you end up getting a minus 10 as well. So the sum of n terms is equal to n over 2, open square brackets, 2a plus n minus 1 d. All right, so we know that the sum of the duration in question, which is 12 months, is equivalent to 2,340. And we know that the duration is n. So we have 12 divided by 2. Then we have 2 times x plus 12 minus 1. Then we have a minus 10 there. So 2,340 is equal to now 2 into 12. Basically, we know that this is going to give us 6. Then 2 times x is 2x plus 12 minus 1 is 11 times minus 10. This multiplies that, and you have 2,340 being equal to 6. Then you have 2x. Now 10 times 11, this give you minus 110, like that. So we can also forward this out, but in my case, I feel like it's much easier to just to divide throughout the equation by 6. And if we do so, we end up having 390, that is if 6 goes into 2,340, then 6 into 6, that's basically 1, and 1 by everything will not change anything because 1 is an abstract figure. So I have 2x minus 110, like that. Now at this point, you have to make x a substitute formula. So we have 2x minus 110 being equal to 390. So just flip the equation because most people have to see it like this. Now transpose it. So you take the minus 110 the other side, and you have 2x being equivalent to 390 plus 110. So we have 2x being equal to now 390 plus 110 will give you about 500. Then you divide by 2, divide by 2. You have x being equal to 250. Now this tells you to say that the first installment is equal to 250 kwacha. So that's the first amount of money that Mr. Temba paid in the first month. So that's basically how you go about solving such questions. All right, let's look at the last example, which is like the most interesting question in this video. So we have this type of a question that says a manufacturer produces 1,200 computers each week. Now, after week 1, he increases production by, in the first place, we're having 80 computers each week. The second is saying 5% each week. So now, these two conditions provide different type of solutions depending on the way a question can be phrased. Let's look at a question that would say this. First question would say, find the output in week 20 under each scheme, which is each condition. All right, so now let's find the output in week 20. So I've been given a duration now. Let's understand what we can do. All right, so let's look at the first scheme, which is condition number 1, which is A, scheme A. All right, so under the first scheme, we need to understand what we have. The manufacturer produces 1,200 computers each week. So which means in every week, the person has to produce. So in the first week, the person has to produce 1,200 computers. Then after week 1, they have to increase. So under the first scheme, we're increasing by 80 computers each week, which means that this will now be in week 2, second week, we have 1,200 plus 80. Then the third week, we have 1,200 plus 80 plus another 80, and it keeps on going. Now this tells you to say that this will now be written as 1,200, then will be 1,280, then again it will be 1,360. It keeps on going. So I've just summed up the top values in each week. Now that I have that, I can now find my output. Now, we need first to understand that this is not the total amount of computers we need to find in this question. We just want to find the output in a given period of time. So our duration is n. So the duration is 20 weeks. Now we need to find what the output would be. So the output will be found by using the nth formula, where we say nth is equal to a plus n minus 1, then d. Now, what is the first term? The first term is 1,200. Now, what is the value of d? The d is a common difference. So it's term 2 minus term 1, which is also equivalent to term 3 minus term 2. Either ways, you pick which is better for you. So 1,280 minus 1,200 will basically give me about 80, as the increment has been given in question. So with that in mind, we can now substitute. So what is the output in week 20? So in the 20th week, we're going to have the following. So we have 1,200 plus 20 minus 1, then times 80. Then the 20th week will produce 1,200 plus, now this will give you 19 times 80, so we do that. So the 20th week is giving us 1,200 plus now 80 plus 19 will give you 1,520. This tells you to say that the 20th week will produce an output of 2,720. So output, this implies that output in week 20 is equivalent to 2,720. So this was under the first scheme. And the second scheme is saying 5% each week, while increasing by 5% each week. Now, what you need to understand is this. Every time you have a percentage and you are looking at the application of APs and GPs, just be mindful that this will give you what? A geometric progression every time you have a percentage. Now, we need to also understand one thing. So if we're increasing by 5%, what do we mean? Remember, in the first week, we're having 1,200 computers. So if I'm increasing by 5%, what is 5% of 1,200? Let's try and see. If we drop a data, we'll have 5% divided by 100% times 1,200. This will give us roughly about 60 computers. So the increment is by 60. So this means that in the second week, we'll have 1,200 plus 60. And then in the third week, we'll have 1,200 plus 60, then again plus another 60, and this keeps on going. If we sum this up, we'll have 1,200, then 1,260, then 1,320. It keeps on going. So with this given, we can now find the values we need for a geometric progression. Now it's just the output, not the total. So this means that what we need to find is basically the nth. So the nth in a geometric progression is given by a, open parenthesis, r to the n minus 1. So if we do up another data, we can look for n, which is basically a duration. What was the duration? The duration was, says find the output in week 20. So that's the duration. So n is 20. So we know that n is 20 and a is 1200. Let's find r. R is equal to term 2 divided by term 1. Or we could say term 3 divided by term 2. Either ways. So r is equal to 1260 divided by 1200. So r will give us about 1.05. That's a common ratio. So in the 20th week, we're going to have 1200, then 1.05 power 20 minus 1. So the 20th week is giving us 1200, then 1.05 to the power 19. All right, so if we use our calculators, you could say that the 20th week will be having about 3,032.3402, and a lot of numbers aside. But anyway, we have to round this off. So we'll say, okay, say for 20th week is equal to 3,032 computers. So we could say that output in week 20 is equivalent to 3,032. All right, now this is not the only type of equation that might be phrased. Another question might be phrased in a sense that they would ask you to say, now it's the same question, so I really need you to understand it. Remember, the manufacturer produces 1,200 computers each week. After week 1, we have an increment in production by first scheme and second scheme. First scheme 80, second is 5%. All right, now let's try and see what we should do if at all they told us to find the total output over the first 20 weeks under each scheme. So find the total output over the first 20 weeks under each scheme. Now remember the data that we have. Now let's look at it under scheme A. Under scheme A, we had the following. We had a sequence that was in the form of 1,200, then 1,280, then 1,360. That was our sequence. Then we also had the following values. We knew that the first term is 1,200, the duration in question is 20, and the common difference is 80. Now, because they said find the total, we need to use the sum rather of an AP in this case, because under the first scheme, the increment is by 80. Not really a percentage, just a number. So we're going to say sum of n terms is equal to n over 2, open square brackets, 2a plus n minus 1, then d. So what is this particular sum? So the sum in 20 weeks is equal to 20 divided by 2. Then you have 2 times 1,200 plus 20 minus 1, then times 80. All right, so we have that. So sum in the first 20 weeks will give us 10 here. And then what is 2 times this will give us 2,400 plus you have 19 there times 80. So sum in the first 20 would be 10. Now this would be 2,400 plus what is 80 times 19 to give us 1,520. So sum in the first 20 will give us 10. Then if we sum this up, this would be 3,900, sorry, 39,000, not really, sorry, 3,900, it's 3,920 precisely. All right, so if I compute this, I was a bit too fast, so solving in my head. So sum in 20 weeks will give us 39,200. All right, that's the number I was really looking to say. Okay, so that's the value. So this tells us to say that total output, okay, output in 20 weeks is equal to 39,200. All right, so that's what we have. So that's under scheme A. Now let's try and see what we should do under scheme B. All right, so in scheme B, so we're having the following conditions. We know that it's 5%, that's one, and this gives us a difference of 60. And that each sequence is in the form of 1,200, then 1,260, then 1,320, and it keeps on going. The answer to the first term is 1,200, and the R is equal to 1.05. So now when it comes to the sum of a GP, there are two conditions you need to understand. So we'll say sum of n can be as a result of A, then R to the n minus 1 over R minus 1. We only use this sum if R is greater than 1. Else, sum of n terms is equal to A, open parenthesis, 1 minus R to the n over 1 minus R. This is when R is less than 1. Now, in our case, we have 1.05, which is greater than 1. So, we're going to use sum of the n terms being equal to A, open brackets, R to the n minus 1, close, over R minus 1. Substituting with our values that we have, we know that n is a duration, which is 20 weeks, so we're having 20. This is equal to 1,200, then 1.05 to the power 20 minus 1 over 1.05 minus 1. Okay, so we can just compute this on our calculators, and we'll have our sum to be equivalent to 39,679.14492. Therefore, sum will just be 39,679. So we could say that, therefore, total output in 20 weeks is equal to 39,679. All right, so let's understand the last conditional question that might be phrased. Now, say that we are told to calculate for scheme A and B the week in which production first exceeds 8,000. All right, let's solve this. Now, under the first scheme A. All right, so under the first scheme, we need to understand that production increased by 80, which means that the difference is 80. But the first production amount was 1,200. Now, since we're looking for the week in question, we need to find the week in which the production was 8,000. So we need to find the week in which the value of n, the nth rather, was 8,000. So we now just need to find the week which is the value of n. So I'm going to say nth is equal to a plus n minus 1 d. So we now know that the nth is 8,000 is equal to the first term 1,200 plus n minus 1, then 80, which is the d. Foiling it out, we have the following: 1,200 plus 80n minus 80. Now simplifying the like terms, we end up having 80n plus, we're going to have 1,120. So 80n is equal to 8,000 minus 1120. So 80n is going to be equivalent to 6,880. So 80n being equal to 6,880, you can divide by 80, dividing by 80, you have n being equal to 86. Therefore, we could say that week 86 exceeds 8,000. Just like that. Now let's try and see what we can do under scheme B. In scheme B, we need to remember that the difference was 60, but the first term still remains 1,200. Now know that the nth is now 8,000. We just need to find the value of n. So another JP, because scheme B had 5%, so we have the nth being equal to a r to the n minus 1. So we have 8,000 being equal to 1,200. Remember, the common ratio was 1.05. Then times 1.05 to the n minus 1. We can divide throughout by 1,200 and see what we can get. Alright, so what we're going to end up having is that if we say 8,000 divided by 1,200, this side just have 1.05 to the power n minus 1. We can reduce this and can reduce this portion here, and we'll end up having 20 over 3 being equal to 1.05 to the power n minus 1. Now at this point, it's the best time you can apply logs. I hope everybody knows logs. If you don't, you can always check out my playlist on the first year math and try and learn logs so that you can apply these concepts with ease. So when we introduce logs, this will be log 20 over 3 being equal to log 1.05 to the n minus 1. So the power of logs allows us to drop the powers. So log 20 over 3 is equal to n minus 1 times log 1.05. Then we can divide throughout by log 1.05. And the other side, log 1.05. This kills that. Alright, so this will give us n minus 1 being equal to, now if we compute this portion here, what are we going to end up having? So we're going to, depending with the way you have rounded off your values, you would find that different values will come out depending with the way you have found your rounded off solution. So in my case, I will not round it off in a different type of way. I'll just put it in the most common type way people mostly just do it. Alright, so if at all we compute that, we're supposed to end up having, if I round this off, 38.8833, and then taking 1 the other side, I have n being equal to 38.8833 plus 1. Then my n is equal to 39.8833, like that. Alright, so what we can do here is to neglect the other values, but which will be a bit shallow to neglect them, but we'll just round it off and say that, okay, because these are days, so we won't really push it to like 40. This will just be like 39. That will be in with 39, because if these are weeks, then this will be like the days, 39 weeks and 9 days. So since our interest are just weeks, we'll just say 39. So therefore, we could say that in week 39, or let's say week 39 exceeds 8,000. All right, so if you have queries about these questions, you can always reach me out on WhatsApp on the line +26077149525. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try to push for that A plus.